This conference will now be recorded.
Hey everyone, our speaker is Tony from Siemens, Tony Mastriani, and he's going to be talking about 3D IC design kits. Tony, all yours.
All right. Thank you, Bobby. So, what I'm going to be talking about are we're coining this phrase 3DKs, and what essentially this is, it's a comprehensive set of design kits, anything and everything you would need to support 3D IC. And we're trying to drive some of these open standards. What really kind of motivated this? Well, let me do a brief intro about CDX. So the charter of CDX, the Chiplet Design Exchange Group, this is a working group under OCP. And our charter really is to recommend standardized chiplet models, workflows, and ecosystem. And we've got a broad set of users. We've got EDA representatives, chiplet providers, folks who have a few foundry and OSAT type suppliers, as well as end users that do these system integrations. So we're trying to get a diverse set of representation to fulfill this charter. A few things that we've done over the last couple of years is we published a white paper talking about chiplet design kits. I'll talk a little bit more about this in some of the slides. JEP30 is a new JEDEC model in a format, CDMXML, that was created, and we announced that in January this year. We're currently working on a 3DIC white paper. We hope to publish that soon. And we're just kicked off this 3DK initiative a couple of weeks ago. So what was really driving this is, as part of the CHIPS Act and other related government funding, there's many initiatives and RFQs that the government is driving to try to drive some standardization and onshoring. So one of these was from the Department of Defense. It's the AP4D. And a section of that calls out for standardized computer-aided design assembly design kits, ADKs, for 2.5 and 3D packaging. Like I said, we took a little bit of poetic license because I think assembly design kit is really doesn't capture the all of the kits. So we're going to call it 3DKs, but essentially we're trying to address this specific element of that contract. DARPA has also put out several RFQs as part of their NGMM. This is the next generation microelectronics manufacturing. This is trying to drive onshoring and bring the capabilities domestically. So this also talks about 3D ADKs is what they call it. Okay, so that's really what kind of drove this. We are actively involved, as well as some other EDA vendors in these programs. And we have agreed, at least on one program where we have both Siemens and Cadence working on a common project, we've agreed to, rather than come up with competing proposals, we're going to collaborate together on these 3DKs. So some of the key assumptions that we're taking is we don't want to reinvent the wheel. So we want to leverage existing standards if they exist and if they're applicable, extend them where they're required. And, where there's gaps, we want to drive some new and open standards. And open is a key word. Okay, so we're really not looking to, take proprietary standards either coming from companies or EDA vendors or end users. We're really trying to come up with something that best captures the intent and have it open as much as possible. Another important tenet here is we want machine readable models. So I think the semiconductor industry has done a good job with most of this, and but some of the traditional packaging OSATs and even some of the multi-physics simulation really haven't kind of taken this machine readable approach in defining design kits. So a lot of it is PDFs. just email exchanges with vendors and stuff. So we're trying to come up with standardized formats that are machine readable so they can be consumed by scripts, EDA tools, APIs, and et cetera. EDA support. So we do want to get alignment and collaboration between the major EDA vendors. We really want to discourage having competing, overlapping standards. So the best way to do that is kind of work together. I mean, this is not rocket science. Some proprietary formats may give a specific vendor an advantage, but we're really looking to have open standards to capture this information, really to kind of move the industry forward. So tool vendor neutral standards, and the idea is the tools and the workflows, we would adopt these standards. So they're part of these workflows and they're supported by the tools. And then we want to drive this throughout the ecosystem. So the EDA vendors, we want them to support that. The fabs, the substrate vendors, the OSATs, we really want to get really alignment on all these fronts. And again, this is initially being driven by government, but we also want, this is certainly applicable for commercial use as well. So this is a high-level summary, and I'm going to talk about each of these in detail, but we have some system on chip, SoC IP libraries. I'm going to focus a little bit more on 3D IC specifics. Chiplet design kits. This is a white paper that we published a couple of years ago, and we're getting some pretty good traction on this. What this is it's a standardized collection of models that we're recommending be delivered with by chiplet vendors. So today there really is not much of a chiplet ecosystem, but we really are trying to drive that and to essentially have a marketplace where there's off-the-shelf chiplets that can be distributed and sold as IP. So this is a proposal for when you those vendors distribute those design kits, they provide those models. Process design kits, well known and very well established in the IC world, not so much in the packaging world. So we want to extend some of these thoughts and principles into some of the packaging type materials. Assembly design kits, I'll talk a little bit about that. There are some efforts ongoing, but there's some additional gaps as well that we'll talk about. Package IP design kits. This is, I come from the IC world, and typically we're very used to dealing with standardized libraries coming from fabs and such. But in the packaging world, it's a little bit different. Typically, they'll get the information from the vendors about, the different connectivity structures, TSVs, bumps, and micro bumps, and then they'll create their own, GDS and left models for those. But the idea is let's try to put that into a standard set of library and kind of package it up. So it's not so much a standard, but more of a best practice to deal with these common elements. And then the last one is material design kits. So for the analysis, whether it be signal integrity, power integrity, and multi-physics, thermal, mechanical stress analysis, there's a lot of material information that's required for the components as within the package, the actual die. And there really is very little standardization there. So the vendors provide that information in different formats. It's predominantly PDF. And a lot of it is, the designer will say, well, I need this type of material, and they'll provide the specifications. But the idea here is to come up with a standardized format, and that information can be captured in a machine readable format. So in terms of the IC libraries, I think primarily the thing that is kind of new for 2.5D specifically are these die-to-die interfaces. This is your UCIe Express, the BOW, and XSR, and et cetera. So from a packaging, 3D IC perspective, the front end models, specifically laugh.lib and Verilog models, are useful, as well as verification IP. And verification IP would have generic type models for these different protocol interfaces. And it applies for both the chip to chip and die to die. So by chip to chip, these are the interfaces that would go offside the chip. So this would be your traditional Ethernet SerDes, HBM, HBM is a die to die, DDR, and those types of interfaces, and they're pretty well established. But as you're doing your system decomposition, it's important to when you're doing that microarchitectural development, you need to identify what the interfaces are, both going outside of the package as well as the internal connections. So the idea is to have some library support for that, and that could lead into tools to facilitate 3D IC architectural exploration. So decompose your system into different chiplets. And what you want to really do is identify the key internal and external interfaces. And then you could do some early validation of the connectivity and the functionality. This is at a high level. And then eventually, ultimately, you will have to select a specific piece of IP, either design it or acquire it. And we want to be able to map from these generic models to vendor-specific connectivity IP. So the CDKs, again, this was our checklist that we came up with, recommending pretty much all the models that are required for a chiplet that would be required to do chip level analysis. And I do expect that this list will change over time, but you can see there's different categories, thermal, and most of these are existing standards. For physical and mechanical, certainly LEF, GDS, OASIS, SPICE are standard formats. There are some gaps though, and specifically for packaging, you do need to worry about the shape of the connectivity structures. The bump, is it a copper pillar? The mechanical tolerances, and there really are no standards out there. So we took an initiative to create a format to capture the mechanical type information, the size of the die, the package and stuff. A lot of this existed in the JEP 30 standard for kind of board level components. And so what we did is we worked with JEDEC, and we asked them if we could extend this format to capture chiplets. So there is an extension in the JEP 30 standard, and that has recently been adopted. And the CDXML format is an XML format that allows us to capture all of this information, both for a package and a chiplet. So it is just a format, and the information for your components, whether it be a chiplet or a package device, would be defined using this CDMXL format. And then the JEP 30 is a very well-structured set of containers for all this information. So the chiplet aspect is new, and the language is new as well, the CDMXML format. And then you have things like behavioral models. You can have a system Verilog, certainly, but there could be Verilog AMS, System C, models to support power, signal integrity analysis, power integrity. So these are all pretty much existing standards. Kind of a new concept to support static timing analysis for system and package level would be to create kind of a high-level .lib model, so you could actually run some die-to-die static analysis and kind of look at the die-to-die timing for the low-speed interfaces. For your high-speed interfaces, you're going to use signal integrity analysis. And then test is an important thing. These chiplets, typically they will be provided as known good die, but known good die is, I like to call it known pretty good die, because it's done, they're tested at wafer sort, which may not be representative of once it's put into a package. So typically package parts, you're always going to run a final test. So we believe it's important to provide the test patterns, so we have the system integrators have the ability to test those individual components, the internal structures of the device as well. And of course, advanced DFT tools are available to do all of your chip level and die-to-die testing through some of these standard.
Quick question. Those tests will be pre and post assembly, the patterns?
Well, the presumption is the chiplets would be tested at wafer sort and delivered to the integrators. So really, these are the patterns that would be required post assembly. I don't see it. We didn't see a need to retest the part that's already been sorted from the vendor. Okay.
Okay, just to
Security.
make sure I understand, you're saying you provide the patterns for the chiplet vendors, right? But the
We're asking the chiplet vendors to provide the patterns, and it may be in an encrypted manner to the system companies that are doing the integration of the.
Okay.
Okay. We're not sure. All chiplet vendors will support that. It's a new model, but it is a recommendation. So we really can't enforce any of these, but this is a recommendation. And the challenge is if you have multiple chiplets in a package and something goes wrong, is there a defect with a particular part? So having the ability to test it, and specifically in the environment it's going to be used, is we believe is important for diagnostics, as well as looking for potential, there could be damage during the assembly process to a part.
Sure.
Yeah, I really need to move a little bit quicker, but we could spend days talking about this topic, and we actually spent months talking about it when we wrote the white paper. And I do have a pointer for the white paper, so it does a deeper dive in the motivation behind these. So I would encourage anybody interested in that to read the white paper. Security and traceability, these are important components. I know OCP has different working groups on this. This is a huge topic. We didn't address this specifically in CDK, but we did want to include it for completeness. And what we have actually in the JEP 30 standard, these models potentially could be delivered in JEP 30, but most likely some of these are huge. You can envision this. So what we're doing at a minimum is we are providing a checklist of all of these models. And when a chiplet vendor enters the information for their part into the JEP 30 part model, they can specify which of these models are available. And there may be multiple, and they can put comments, they can include documentation, and potentially they can deliver the models through the JEP 30, or that would be done more traditionally like an IP vendor. Once you're under contract, an NDA, you would get access to those more detailed models. Okay, process design kits. So the technologies for silicon and your type 3, 5 material foundries, typically these are pretty mature, the design kits for that. So technology files typically are provided by these foundries. They include DRC decks, LBS decks, could in some cases design for manufacturing, extraction rule decks, and then circuit design kits, your PDKs, and these are kind of schematic driven macros to support analog and memory design. So nothing new here. We're just saying, that this is kind of the state of the industry today, and we want to continue supporting that. Silicon interposers are new, but I think largely the files are the same, DRC, LBS. What we believe really new here is for the organic substrates, and this could be your substrates and organic interposers, stack up fan out type technologies. We would like to see kind of PDF replace PDF files, which is typically how that information is provided, and design rule manuals. So again, these are all PDKs. We'd like to see that information provided in a more machine readable format. So the idea is creating a PDK for these organic structures. Okay, assembly design kits. So this was an idea that was initiated out of a white paper from Intel. they have proposed to have a common set of rules to facilitate interoperability between chiplet vendors. So when they get assembled, each of the chiplets on there would comply to a common set of assembly rules. And they proposed a standard format, and they actually approached each of the EDA vendors and asked them to support this initiative. And each of the major vendors did agree in principle to do this. Synopsys proposed a format called MDXF, and that addresses essentially the rules for defining the bump connectivity on a die. So it is focused specifically to the chiplet. This standard is they're driving the standard through SI2 as an IEEE standard. We're both Cadence and Siemens have agreed in principle to support this format, but unfortunately it's been very difficult to get access to this. So we're really trying to, until we see it and provide some inputs. So that's a question mark. I think we're open and receptive, but if it meets the needs and it's open and accessible to users and other vendors, we're supportive of it. Alternatives, if for some reason that doesn't work out, 3D blocks is a new standard being driven by TSMC, which is opened up, and possibly even a JetX standard. One of the things that is not addressed in MDXF are outside the die. So this is more in the package, different rules. It may be die-to-die rules and spacing to mechanical components. There's a whole slew of other connectivity or rules that need to be defined, and they're not within the scope of MDXF. So this is going to require a new format. I don't believe it's our understanding that MDX does not plan on supporting this. That could change, but that's our current understanding. So 3D IC assembly decks. So this is a format to describe how you stack up all these components inside of a package. And again, TSMC initiated the open initiative for 3D Fabric Alliance, and they proposed this 3D blocks format. It is a work in progress. Each of the EDA vendors is working on that, and I'd say similar to MDXF, we are open and receptive, and we're open and receptive, but it's still a work in progress. So we do need to make sure it meets the needs and it does support all the formats out there. So we do plan on supporting that, but there are other potential competing standards, and if this doesn't work out, we may want to consider another alternative. But right now, I think we do want to adopt 3D blocks. So this format captures the stack, how all the components are placed, whether they're flipped, where the pins are, and all that information. Stuff that would not be in your normal GDS left-def formats. They have a ProPad extension, so they are looking to add a lot of different things into 3D blocks. And assembly rules is something that is not supported in 3D blocks, but again, this could be an alternative for this up here. Okay, so this is the kind of the connectivity cells that I talked about, your bumps, microbumps, C4, TSVs, hybrid bond. So the physical models for when you're doing your package design and analysis left, GDS. CVMXL has some of that mechanical type information in 3D blocks as well. And then electrical models. So the parasitics for some of these complex structures like TSVs, providing models for those, possibly custom ERC type checks and ESD checks. schematic symbols for more of the analog type structures, and possibly parameterized macros. And then we have the material design kits, and here the idea is these are the material properties for your packaging substrate components. This would be PCB, your die, your chiplet die, substrate, interposer, and even the mechanical, some of the mechanical material properties for the components, could even be for the package itself and the board. So this would include things like electrical properties and thermal-mechanical, thermal conductivity, and then for doing mechanical stress and warpage and reliability analysis, some of these coefficients, thermal expansion coefficients and Young's modulus. Now, one of the nice things about the JEP 30, they already have support for defining these material properties. And that is, so it's already existing in CDMXL. So we considered including the material design properties in JEP 30, but the issue there is we wanted to limit the focus just for chiplets. Because if you think about it, an interposer, if you're designing an interposer, it's going to be very custom to the design. And, that is something you would not put in kind of a standard component library. So the idea is we can leverage the format, but all of the components inside the package that are going to be customized, your substrate is most likely going to be custom designed, your mechanical package and lids and stiffeners. So we didn't feel really that was necessary to include that in the JEP 30 standard, but the format stands this. So this would be a standalone format. So your analysis, your thermal mechanical analysis tools, signal integrity would then read this CDMXL format to get that property, those material properties into the different analysis tools. Okay, so this is just kind of a summary of where we're at in the industry. So in the IP, I think in general, the models here are mature, so we just want to continue to adopt that. The die-to-die interfaces are new, but the idea would be to adopt the standard PDK model for the for these models. The CDK, this is the chiplet design kits. It is actively supported in the JEDEC, and the idea is we really want to promote this and have the industry and the EDA vendors adopt this. So for the PDKs, again, this is pretty standard for silicon and your gallium arsenide and type 35 properties. Silicon interposer, just pretty much continue to adopt. That isn't pretty mature today, so I'd say that's in production. The organic substrate, this is new, so we need to have some further discussions on how we want to do this. There are, some vendors do have, chip type, caliber type checks for these, but some of the structures are very different, and a lot of the IC tools are different, and there's different shapes and stuff. So there may be some new work that needs to be done to define these PDKs. I talked about the ADKs. Consider the MDX 3D block formats, the common assembly rules. So this is the 3D blocks format. There may be others. ADK, EDA adoption and support the ADK format. So again, this is pretty mature for your traditional ADK assembly or rule decks. Packaging K, this is a new proposal, and it's really just promoting that and provide some examples. So I don't think this is necessarily the standards exist to capture these objects. So it's really just the notion of creating packaging this up into libraries, reusable libraries. And then the MDK is new, and we've actually just launched an initiative in the CDX group, and we're looking for volunteers to help us define this standard. So we, for the CDMXL, we've been meeting every other Thursday. So we're proposing on perhaps the alternate Thursday, we'll meet bi-weekly and set up a meeting on that. If anyone's interested in joining this group, send an email. This is my email address, and we'll get you invited. This stuff, all the work here will be posted and it's accessible, through our standard OCP practices and policies. We are considering doing a joint white paper, Siemens and Cadence, and anybody else in CDX that's interested might be interested in having maybe another analysis company join us, ANSYS, for example. And then there is an NGMM conference in August, so I'd like to present this to the broader, government community, talk about this effort, and hopefully we'll have more to talk about once we get the MDK thing going. And other topics, again, these ADKs and organic PDKs. Okay. I'm over 3 minutes, but I can take a couple questions, but I'd like to limit it to the next 5 minutes or so.
Thank you. Any questions for Tony?
Okay. Either I did a really good job or nobody knows what I'm talking about. But feel free to reach out.
That was pretty good.
And
maybe a quick
meetings,
one.
Yeah.
If you don't mind, maybe a quick one. So this is like about 3D die, right? What is 3D? Like, you mean like stacked die?
Well, when I say 3D IC, it's kind of a catch-all. It supports 2.5D and 3D. That's kind of the industry term, and I do believe that that will coexist. I mean, 3D, there people are doing stacked dies today. The actual, what I call it, true 3D, where the place around tools are can automatically break a very large ASIC into multiple chips and do all the optimization. That technology, those place around tools, there's some prototypes out there. It's work in progress. That's a couple of years before that's away. But even once that becomes mature, you're probably going to be limited to probably 3, possibly 4 stacked die. And if you want to build a system larger than that, you can still leverage 2.5D to integrate multiple 3Ds. Some people are calling that 5.5D. But so when I say 3D IC, 3DKs, we're talking about 2.5 and 3D. And there's so many different packaging technologies. And,
Sure.
Optics are getting in there. So this it covers a very broad set of applications. So not all of these are applicable for 3D, but many are.
Sure. But do you know, by the way, if we have any like die-to-die standard interfaces to connect those, like 3D
Oh yeah,
stack?
I'm not sure. I mean, there are several standards out there. I mean, for the die-to-die interface. Oh, for 3D. For
3D. I know there is like Bow and there is UCIe.
Yeah,
and those.
yeah. Oh, yeah. So I saw one paper for a 3D, but I haven't heard much talk about it. I mean, with 3D, you're basically just talking to a couple of microns, possibly up to, if you have to go from the bottom stack to the top, you're talking about very short geometries. I don't think you need those high-speed protocols, but since they are different die and they may have different on-chip variations, you have to be careful about timing. But I don't know if those interfaces really are going to be applicable. I've seen one paper, but that's all I've seen out in the industry on a 3D protocol.
So Taufik, UCLA has a 3D protocol. I'm going to see if we can bring them back in a couple of weeks that they want to open up and see if it can become a part of an ODSA standard, so to speak.
Cool. Yeah, Yeah, invite me to that,
Okay,
Bobby.
great.
I'd like to listen to that. Okay, I do need to go. One last question.
Actually, when you say please join the white paper, you mean that join the CDX meetings on Thursday, right, Tony?
Yes, that is correct.
Okay.
And I've got a pretty good start on this white paper. I do want to collaborate, and so I definitely want to have at least cadence, since we're already working on this. It's part of one of our joint engagements that we're working on, and I'd like to have a kind of a non-EDA person in CDX just to join it. So, but the working group, I think there's lots of work to be there done. So we're looking for people who understand, the analysis tools and the material properties. The format, I think, is in pretty good shape. So it's really just defining the type of information that we want to capture and have some working examples. Maybe even do a prototype.
Super.
All right. Thanks, everyone.
Thanks, Tony.
You're welcome.
Okay. Let's see. Shab's here somewhere. If I can find him. Oh, there he is.
I'm here.
Yep. Okay. So the back half of the meeting is Shahab's going to talk about further progress on our die-to-die comparison spreadsheet for 2023. And it's all yours.
Thank you, Opie. I just want to update the group that where we are standing. Last couple of weeks that we met, we kind of finalized the FOM. What we are adding and to the existing FOM is the effect of the latency, number of layers, and the bit error rate after FIC. Previously, we had bandwidth, shoreline, and energy per bit, and now we are adding basically latency, number of layers per package, and bit error rate after the FIC. This is going to be a new FOM, hopefully for 2023, 2024. We can actually compile all the data based on this FOM and basically publish it and make it public available to everyone. There are a couple of information missing from the last Excel sheet that we basically collected for this new FOM, especially the new component that we are adding. First,
Did you mean to share any document, or you just?
I'm sorry?
Did you mean to share anything on the screen, or you're talking?
No, I'm just talking about it because I'm asking for everybody's on the call help, not
Okay, no
presenting the
problem.
data.
No problem. Yes, no problem.
Yep. But basically, there are a couple of information missing from the last Excel sheet that we collected data. Number one is the number of layers. Only 2 or 3 participants actually reported their packaging type last time, which I believe every one of them said 727. This time, I think we have to ask for more information to identify the number of layers that we need. Previously, we reported latency based on a bit error rate of e to the power of minus 1 e to the power of minus 15. This time, we're going to report it based on a whatever FIC that they have to include it in our FOM. This coming Tuesday, I'm gonna plot whatever information that we have based on this new FOM and present it to the audience who are joining us on Tuesday morning at 9. If I get the basically everyone confirmation, then we're gonna go ahead and share the Excel sheet to all the people to update the previous data. Some of those files are no longer available or exist, and there is a huge list that we really like to compile the data for them and collect the data and add to that Excel sheet. If you or your organization are have any interest to be part of this activity, please join us on Tuesday at 9 a.m.
This is the sheet Shahab's referring to.
Yeah. For example, the information that is missing here is right now the number of layers and latency. We really like to get those two data and also update it. As you can see, some of this files at those time got retired, OpenHBI and others, which we need to replace them with the new ones.
So one of the topics I wanted to have a discussion on, if we can, and maybe is that I'm aware of at least, I would say 8 to 9 chiplets that have been implemented, some with Bo, some with other proprietary technologies, and whether there's any meaningful way to capture that physical implementation, either as a part of this sheet or a second sheet, and show progress on the reality versus theory.
I think we went over this discussion one time, Bobby, but it's a good actually to talk about it again. Do we want to basically list all of them? For example, let's say if we have a 5 different implementation of the XSR, do you want to basically compare those XSR, or should we take an average and include it in this Excel sheet? I think that could be a question maybe for everyone.
What's the purpose of this sheet?
This sheet as things stand?
I'm just curious because how is it going to be disseminated, or what's the audience for the?
Well, it's rather been a self-disseminating spreadsheet. We really its purpose originally was we had a whole bunch of multiple proposals of different kinds, serial interfaces, parallel interfaces, you name it, and we thought when we did it that a single sheet that first captured all the information on a common set of metrics and then had clear definitions for each of the metrics allows designers and other people to sort of compare them on apples to apples, and it's sort of been good doing that. And going forward, I'd like to sort of see capture who has implementations, how those implementations match up to the claims of the spec, and sort of say which spec made reasonable, realistic assumptions, so that the what we thought could be implemented is actually implementable. Andreas, you're going to say something?
No, I was just going to say that I'd like to participate, but I think it's a little bit difficult, and there may be others in my position too, where I just don't have, like, I have conflicts, right? So I can't attend the meetings, and so having things synchronously done, I think, is a blocker. I think it either have a shared spreadsheet where we can contribute asynchronously, or have a GitHub repo, private one, where we can do pull request, add data, or something like that. But I'm struggling with the synchronous nature of some of these calls.
Got it. Shahab, do you want to comment on that? I think our plan is the synchronous nature to plan the metrics, but you should be able to update this on your own time.
Correct. I think what we're going to do this time is that we're going to prepare an empty one first and distribute it and collect basically information from owner or representative from that file. If you or your organization has a file, I think you are the best person to jump in and fill that Excel sheet for that specific file. That's what we did, by the way, last time. For example, for PCIe, we had one volunteer from Socialnext, and he actually, Turo actually, he put all the number for PCIe Gen 5.
I just don't see this being useful because to customers at least, or people considering this, because it's not accessible, and then the vendors need to own this, right? So they should be able to put their information in and then link to whatever additional information. So the first thing you'd want to see is, I want to compare these 4 vendors or whatever, right? Or link to that. I mean, I just don't see.
I think the whole purpose was not
this whole once a year thing, and then nobody looks at it. I don't see the point.
No, we're confident that's not true. We that part we know is not true, Akash. Quite a few people look at it, reference it, and it's also been used in a couple of papers. So that bridge has been crossed.
And
Okay.
one common catch, we are not comparing vendors. That's the point that I don't want to, for example, see 5 different XSR here. That's why my message was, if you're planning to do that, at least my intention is to either pick one or take the average. We just want to look at the different available solution, and I'm sure different body has different needs. For example, I don't care about latency. Somebody else may care about the latency. Then they can see, okay, what are their availabilities, and then based on their judgment, they can narrow down and pick one that's best suited for their needs. We are not going to be here and say, okay, company X and Y XSR is the best. Go ahead and buy from it. This is not the intention of this Excel sheet.
But Andreas, one question to you. For you to fill it in offline, or for somebody from your company to fill it in offline, beyond the sheet, what do you need, or what can you use? What kind of information do you need?
I mean, so I think if somebody has a template, right? I mean, if you think of this as like a GitHub repo kind of thing, right? Then what I think would be very useful for me and others would be that make it public, right? Right? I don't think having things hidden behind walls is
No,
useful.
this is public.
Well, yeah, but pseudo public. There's a hash key, right? Like it's not necessarily very accessible, right? I find I can never find this link to this document.
Okay, that's fair. Okay, we can fix that. Okay.
And so and then so imagine if you had everybody would supply data with some template, right? And then it's an hour work to basically assemble that into a spreadsheet, right? So everybody can work in their little interface and own that. So nobody would have to edit a master spreadsheet, but you know what fields you have to fill in, and then you would have a kind of a dashboard, right? Anybody's looking into 3D, 2D chiplets, right? It's for yeah, I think I found I think I've had these spreadsheets in the past, right? When I've at DARPA and Net Zero ASIC, right? Like you got to know the lay of the land, right? So this is an incredibly useful like dashboard of what's out there, right? I wouldn't use it as it's not meant to be a figure of merit to compare IP, like Shab said, right? So, but I think that working on the public nature of it would be really useful, and coming up with a model where we could easily add experimental interfaces and
So, but there's one thing. What Shab has been spending a lot of cycles on consistent definitions of terms. Like if we say latency, we mean it from point A to point B, so to speak, right? And this is the latency we want to capture in the. So we'd like to get some buy-in for that from the companies filling in the information as well. Right. So when we say latency, we mean it at this bit error rate. We mean it from this point here to this other point here. And we'd like to find some way for all the companies filling in the information to get some buy-in. And that was the one thing where we want some synchronicity for everybody to say, yes, we buy into the metrics, we buy into the definitions. If that makes sense.
Yeah, and I know that fight both on latency and energy efficiency, right? On some of these interfaces, right? You look at like a massively parallel interface, right? It doesn't really matter. I mean, it matters what the energy efficiency is on the wire between the chiplets, right? But then what's the energy of the link layer, right? And implementation and same thing with latency, right? Like bump to bump doesn't really matter as much as end to end, right? Information to information exchange. So, but yeah, first thing is defining it, right? Because otherwise the merits.
Exactly.
Yeah.
So that's the one part where we'd like to sort of make it synchronous and have one meeting where we at least review, or at least have one or two meetings where we review these metrics and say, look, we've worked on these. This is what we think, and then you guys fill it in on your own time whenever.
And I would suggest that the filling in part would be done in a repo, not in a spreadsheet.
Fair enough. Okay. But Shab, you already have some ideas in that direction, right?
Yeah, we can use that. Because one of the feature that we are adding. Sorry, two comments. Number one, to add what Bobby basically mentioned previously, we prepared a PowerPoint presentation about every basically lines that people can edit and modify or add numbers. An explanation of, for example, what do you mean by data lines? What do you mean by data wires? All the basically green cells that right now you see, it's a basically user editable. And we had a definition and one slide attached to it. I can make that one also part of that Git repo that you mentioned, Andreas, and then people can read that guide document, how to fill it in. Another feature that we are adding to this FOM is that we can eliminate some of the parameters inside the FOM. For example, if you don't care about the power, you can come and basically turn it off and again compare everything. If you don't care about the bit error rate, turn it off, or if you don't care about the latency, any of those. To address that, I was planning actually to move this entirely to a kind of Jupyter notebook format and share it online. Then people can put true and false in some of the parameters and then get the new FOM plotted. I believe moving it to GitHub is going to be much easier that way as well. Then anyway, we have to get off of basically the Google doc format and either go to Jupyter Network, or we can tie the Jupyter Network to a GitHub database.
Sorry, I have a question. So is this sheet supposed to compare the different die-to-die files? Because I don't see UCIe, for example.
Yes. Shab, you want to answer that or me?
Yeah, this is a 2020 version, and there
Ah,
are at least 10 or 15 new basically
yeah.
file that it's not part of it, and we are planning to add as we go. That's
Okay.
we already have 5 for one rep at least for some of those. But if you're aware of any file that we are not listing it in the meeting on Tuesdays, please feel free to suggest that we are open to include everyone.
Yeah, and it would be useful if we can have access to that slide deck that someone just mentioned, explaining the different metrics.
Okay, sure.
Thanks.
So,
Do you mind giving me an email? Then I will try to share more information.
Sure, yeah, I will.
this is a reference. This is going to be the third iteration of our sheet. We sort of do it every couple of years. So we started this in 17, either 6 or 7, as we did in 17, then we did 9. So every 2 years we do an update of this sheet. Any other thoughts, questions on this?
Maybe just the depressing comment that there's 15 more die-to-die interfaces now. Like
Yeah.
it's like the Moore's law of die-to-die interfaces, right? It doubles every year or every 2 years.
But some of them are getting retired, you know.
Seems like the retirement age is not as fast as the birth rate.
The number is multiplying, and the speed is multiplying. So there's something quadratic in there. Any other thoughts?
Shahab, just one question. So if, let's say for XSR, if you have info from 4 vendors, are we going to average the metrics then and just put up a single column here?
Theoretically, we have 3 options: include all of them, which I don't believe we get that much of participation if we do that. Then one option is averaging, one option is to pick only one of them and attach the name of the vendor. We had this problem with, I don't want to name the vendors, but there was last time in 2020, we had 2 companies providing data, but as soon as one of the company basically saw the result from the other company, they pulled out. I think that's going to be the problem, and I don't have any solution for them. I'll open for feedback from your side on everybody. Do you guys think average is a good idea? Do you guys think pick the one that is more comfortable to share, or put all of them in, which I don't believe is feasible, but I'm open to all.
I'd recommend publishing data that people are willing to publish, like the XSR, for example, right? It's if it's a standard, that's what we want to compare to, right? Not an implementation.
But I think there is merit, right, in saying this is what the standard projected, this is what an implementation is, either median across implementations or average, to sort of give designers some perspective on if you're going for the next generation, this is going to be the gap between what you think will happen and what will happen.
Well, then you need to cover what is the process node, you know, who's the vendor, even if you don't put the vendor name on there, right? There's so much missing that would be useful to a designer. That's why I'm questioning this thing, right? Because it's out every couple of years, and let's say that there are 30 or 40 standards. So this is what I'm struggling with, right? I mean, to be honest, right? We've got AIB1, AIB2, and you know, BOW fast, and I mean, how many different bunch of wires options are there now, right? And there's advanced and all the different packaging options to be useful to somebody, right? I think that's the thing that I'm struggling with in this format, and none of it's vendor specific, because as you all know, as a vendor myself, we don't have information right now because we're early, but vendors that do have information, they're guarding it, you know what I mean? So it's a catch-22 situation to a certain extent.
What's your recommendation, Kashna?
No, I'm struggling. If I had a recommendation, I'd give one. I mean, I'm struggling with it, which is, how is it going to be used? And that was my original question. Andreas made a point. He would never even find this. So on the one hand, I'm hearing that it's been very useful, and maybe lots and lots of end designers are looking at this and choosing which standard to use. I find that doubtful, although I'm not questioning BAPI. Okay. I just find it very difficult to understand how it's going to be useful in its current form, right? So I know you're putting a lot of work into this, so I'm just like, is there any, just take a step back and say, look, somebody's looking at, hey, I need a die-to-die interface, and how do they find this? Then how is it useful? Is it timely? Is it, you know, who do they contact for more information? I mean, I don't know.
So Cash, this is Anu. So I did use this in one of the earlier forms. I haven't looked at it recently, but I did use it in its earlier forms when there were multiple, like he's showing the multiple forms of the bow as well as the AIB, in order to understand, because I feel this one gives you a fair point of comparison. For example, you know, latency measurement from point A to point B, they're not necessarily defined the same everywhere, but this attempts to create some kind of a goodness factor, saying, you know, this is what we think is correct. So I feel it's it has value in that sense, because I was able to use it to my benefit.
Okay.
All right. On that ringing endorsement, Anu, it's a good time to end the meeting. Thank you.
I always have the final word. Yep.
That's awesome.